And so in Flowmaster, when we solve, we're going to solve for normal depth. And that'll give us the depth within that segment of pipe. So the material of the pipe is PVC. So it's a pretty smooth pipe system. So typical roughness coefficient, managed roughness, is like 0.01, something like that. Your channel slope is going to be that minimum, at least that minimum slope I mentioned. So let's say it's 0.04, and minimum diameter of a gravity system is 8 inches. And then let's just say our flow is a half a CFS. Okay. So for that segment, we do the calculation, we get a 4-inch depth. So I assumed an 8-inch pipe. For that flow and that slope, that gives me a 4-inch depth. So for that segment, is that pipe sized okay? Do I need to make it bigger, smaller, bigger? Can't make it smaller, so 4 inches is good because it's less than 75%, right? So what you're going to do is you're going to do Flowmaster for each of those pipe segments between the manhole, estimate your depth, fill out that table that I showed you over to the right, and check that pipe size. If your depth, just to keep it simple, exceeds 6 inches for an 8-inch pipe, then you need to think about using a bigger pipe. So the goal here is you're going to analyze each of those segments, do the hydraulics, calculate your depth, and then check to see if that 8-inch pipe is appropriate size. Yep.
So for pipe sizes, it goes like every 2? So
Yeah, it goes 8, 10, 12, 15, I think, or 16, sorry. Yeah, and I'll tell you that you won't have to go too much bigger. If you need a really, really big pipe, then you probably messed up a calculation somewhere. Okay, so this is fairly straightforward, not complicated, pretty simple, so hopefully it makes sense. So again, your goal here is you're gonna lay out your system, you're gonna figure out your pipe sizes, figure out the inverse of the pipe, and and then it's gonna be part of a construction plan, so you show your manholes and your pipes. Okay? Yeah?
So the material was PVC, right?
The material is PVC. And that's pretty standard in Florida, is PVC for sanitary pipe. Yep.
Also about the Flowmaster, I don't know if other groups had an issue. We had issue like saying that we had only 7 days and our license would expire. So we tried to open again the pump pack, it didn't want to open for me. And it showed for Flowmaster, like I did in those 7 days, but I'm not sure it's gonna be opening in next.
And
So
for
for the
contact,
Culvert Master as well.
yeah, I had to contact support
Yeah.
and they like unlocked it. But
Okay.
Yeah. So I guess.
There's a contact point at
It is.
UCF that will basically
Okay.
turn it over for you.
Perfect.
Yeah, I guess if that happens to you, you may have to call and have it unlocked. Yeah, I haven't, it's odd. I personally haven't experienced that, but yeah, if you do, you should hopefully take care of that. Yep.
And just to be sure, we're trying to keep the slopes the same along every segment pipes.
You don't have to do that. I mean, the thing you got to think about is, your existing ground is at a certain slope, right? So you have to just think about the slope of your pipe relative to that ground, because you got to maintain a certain depth of your pipe. But yeah, if your slope is the same, if you could design it that way, that makes it really easy for the contractor.
And we're not going to smooth that contour out if it's big crazy.
Yep.
How is the normal depth related to 8? Is that 75%? Like it has to be 75% of the 8 inches, or?
Yeah, so to be more technically correct, it's 75% of the cross-sectional area of the pipe. So I said 6 inches, just to keep it simple, because you have an 8-inch diameter pipe, so 6 is, 75% of 8. But as long as your depth is 6 inches or less, that pipe size is appropriate.
And 8 is just what we're gonna use by,
That's the minimum pipe size.
okay.
So my suggestion is start with the minimum pipe size and see if that works. If it works, very good, because that's gonna be the cheapest pipe system to design.
And how do you know if it works? Like,
How do you think you would know?
if the flow.
Who can help them out?
The normal depth has to be less than 75%. That's it.
Right, so if your normal depth is less than 6 inches, because that's the depth of flow of your pipe, then you're good. Does that make sense?
Yeah.
Okay? Anybody else? Yep.
Are you trying to keep the velocity under a certain standard or?
As long as you meet the minimum slope, you're fine. Again, in Florida, you typically wouldn't have an issue with a maximum slope, a maximum velocity, because your pipes are generally gonna be placed fairly flat. But in certain parts of the state, you would certainly have that issue potentially, but we won't have that issue here. Yeah,
So the idea with keeping it close to the minimum slope would be that you would reduce construction costs, right? Because you don't have to excavate as much.
Yeah.
Go down deeper.
yeah, that's a good point. So, yeah, if you can minimize the amount of excavation, then yeah, it's just cheaper to construct, for sure. Yep.
So related to the placement of the pipes, does it follow any other? Does it follow the same way as a storm drain, where you have to excavate and create make a bed out of stone and?
Very similarly, yes. So you would excavate a trench, typically. You would place your structures in, where they need to be located, and then underneath that structure, you would typically have, you might have some type of aggregate or something to help stabilize the bottom. And then same thing with the pipe. You have to meet specs, you excavate it out, it has to be compacted for the pipe to sit on, and then as you backfill it, you're compacting as you go. Yep. Yes.
Is the lateral specific size as well, like 8-inch minimum as well?
The lateral would be 6 inches. Yep. Yeah, and again, most residential units, you're not producing a lot of waste effluent. You're just not. I guess if you had a really large family or a lot of people that live there, you obviously would produce more. But again, most, the average American family is, 4 people plus or minus. So you're just, just not producing a lot of flow. So the gravity system, from a hydraulic standpoint, isn't terribly complicated. The lift station is way more complicated, but not the gravity system. Anybody else? Okay, so that is all for tonight. I will